Hello, geometry classes. Today we're going over the surface area of pyramids. So, let's fill in some blanks. A pyramid is a polyhedron in which one face, we're going to call that the base, can be any polygon, and the other faces, we're going to call these the lateral faces, are triangles, and they're going to meet at a common point. We're going to call that a vertex. Sorry, that was kind of hard to read. So we have a picture down here. Our base, in this case, is a hexagon. The point up here, that's our vertex, and all these lateral faces that connect the bottom base with that point up top, they're all going to be triangles. So an altitude of a pyramid, you can see it right here, is a perpendicular segment from the vertex to the plane of the base. So that's kind of like our height from this base up to the vertex. So that is going to be our height of our pyramid. That is the length of the altitude. A regular pyramid is a pyramid whose base is a regular polygon. Remember, that means same side lengths, and whose lateral faces are congruent isosceles triangles. So we have an example of a regular pyramid here with our square pyramid. The base right here, all the side lengths are equal to each other. The slant height we're going to call L. So the slant height is different from the height of our pyramid. The slant height on our picture is right there. It is the length of the altitude of a lateral face of a pyramid. So remember, that goes from point up top down to the bottom of that triangle. The lateral area of a pyramid is the sum of all the congruent lateral faces. And finally, our last blank is the surface area. The surface area of a pyramid is the sum of the lateral area plus the area of the base. So we have this picture down here of our pyramid kind of ripped open. We tore it from the top, I guess. And to find the lateral area, we need to find the area of these triangles. The lateral area is everything besides the base. Now, looking at one individual triangle, its area formula is 1/2 times S times L. What is S? That is the length of the side of the base. L is that slant height, that's the height of the triangle, the height of the lateral face. So we have 4 of those. So to get the lateral area, we have 1/2 times the side length of the base times the lateral height times, in this case it's 4, but imagine if we had, say, like a hexagon. How many triangles would we have there? Sorry, my drawing skills not super great. We would have 6. It corresponds to the number of sides. So that would be n. And if you think back to what we were doing with our area formulas, what does the side length times number of sides give us? That gives us the perimeter of the base. So that's going to actually give us our formula, which is going to be 1/2. Instead of S times N, we're going to say perimeter, P times our slant height, L. So there is our formula. Now for the surface area, which is the area of all of these lateral faces plus the base, all we need to do is simply add the base. And that is our surface area formula. So write those down and we're going to practice with this stuff. So looking at the first example, we're going to find the lateral area of this pyramid. So the lateral area using our formula above is 1/2 times perimeter times slant height. Now looking at the perimeter, that is something we can do without doing any extra work right now. That length is 10, that length is 10, that length is 10, that length is 10. So the perimeter is 10 plus 10 plus 10 plus 10, which is 40. Now the slant height isn't something that we do not have. Slant height is going to go from that vertex down the side, kind of like you're walking down the side of the pyramid. And I want you to think about this triangle right there. And I'm doing a horrible job of highlighting that, but think about this. This is on the lateral face. This down here was 10 all the way across. We're being told that that's 13 over there. And if it's 10 all the way across, that means that this part is going to be 5. So we have this triangle where this is our slant height. This is our lateral edge, and that is 1/2 of our base at the bottom. Now you might already know what L is, but if you don't, let's run through it really quick. 5 squared plus L squared equals 13 squared. 25 plus L squared equals 169. L squared equals 144. And our slant height is 12. So now we got what we need. Our perimeter is 40. Our slant height is 12. So our lateral area is 1/2 times 40 times 12, which I believe is 240. See, I'll double check my work. I don't want to write anything down wrong. Yep, 240. Now, to get the surface area, all we're going to do is take our lateral area and add the area of our base. In this case, since the base is a square, what we're going to do is our lateral area is 240. All we're going to do is add the area of the base. And how do we find the area? Oops, sorry about that. How do we add the area, or excuse me, how do we find the area of a square? Just take side times side, which is 100, to give us our final answer of 340. We can say units squared. Guess I forgot to do my units for the last one. For the second example, a hexagonal pyramid, a little bit harder. Lateral area, still using the same formula, 1/2 times perimeter times slant height, which is nice in this problem. We usually are given the slant height, kind of walking up the pyramid. So now we just need to find the perimeter. Well, the perimeter is the number of sides, 6, times the side length, 6, which is 36. So our lateral area is 1/2 times 36 times our slant height, which we were given as 9. Multiplying that all out, you should get 162 inches squared. For the surface area, we're going to take our lateral area and add the area of the base. Now we know that this is 162, but now we got to find the area of the base. And we got to think back to our last chapter. How did we find the area of a regular hexagon? We needed, what do we need? We need 1/2 times the apothem times the perimeter. We already found the perimeter in the previous problem. That was 36. Now we just need the apothem. And I'm hoping you recall about hexagons. What is this central angle right there? When we cut it in half when making our triangles, well, we did 360 divided by 6, which was 60, and then we divided it by 2 and we got 30. So this was 30 degrees, meaning this is a 30, 60, 90 triangle. Now across the bottom, The side length of the hexagon was 6. So when we cut that in half, it's 3. And if you remember our ratios for our 30, 60, 90 triangle, how do we go from the short leg to the long leg in a 30, 60, 90 triangle? We multiply by the square root of 3. So the apothem is 3 times the square root of 3. So to get the area of the base, to get our capital B, we need to do 1/2 times 3 root 3 times 36. And we're going to keep this as an exact answer. So when I type this on my calculator, all I'm going to type in is 1/2 times 3 times 36. And then I'm going to stick a square root of 3 on the end. Now if you do that with me, I get 54 square root of 3. So that is the area of our base. And the surface area, not going to rewrite it much different than this. I'm just going to rewrite it here at the bottom. Our surface area is 162 plus 54 square root of 3 inches squared. Can't add them together. They're not like terms. So if we're going to keep this in exact form, that is our surface area. All right, for this last one, Great Pyramid of Egypt. Got some big numbers going on, so we have to be very careful with this one. Let's start with our lateral area. So the perimeter is going to be, looks like a square. Along the bottom, we see these little notches, meaning that they're all the same length. So our perimeter is 756 plus 756 plus 756 plus 756, which is 3,024. So there's our perimeter. Now we need the slant height. And we're given the height of the pyramid from vertex down to the base. What we need to find is this slant height over here. Do we see it? I'm hoping you see it. If we make this right triangle right there, we'll be able to find the slant height. So this is 481. Now across the bottom, here's where you got to be careful. Take a look at our picture right here. The whole way across is 756, but we drop that height down the center. So the bottom of our triangle, our right triangle that we're working with to find the slant height, isn't going to be 756. We're actually cutting that in half. So you got half of it over there, you got half of it over there. So that means this is going to be 378. Now to find L, we got to use Pythagorean theorem. 481 squared plus 378 squared equals L squared. Running through that, we're going to have some very large numbers going on. So it looks like we got 374,245 equals L squared, and we're going to take the square root of that. Ugh, not super nice. Looks like we get 611.76. Now we're going to round that. You can keep the whole decimal if you got your calculator handy, but otherwise let's just use this decimal for now. So to find our lateral area, we're going to do 1/2 times the perimeter, which is 3,024, times our slant height, 611.76. And that's going to give us, holy moly, 924,974, about 0.57 square feet. Yikes, that's a big number. For the surface area, all we're going to do is take that lateral area one more time, add the area of the base. So I'm just going to draw an arrow instead of writing that number again. Hopefully you're okay with that. The area of the base is just 756 times 756, which is, give me 1 second, another quite large number, 71,536. So we're going to take that number, add it to this one to get our final surface area of oops. 1,496,510.57 feet squared. So when going through your homework and doing these pyramid surface area and lateral area problems, what you're going to have to do is use a lot of right triangles to find slant heights in different ways. So be thinking about Pythagorean theorem. You're going to be needing to find the areas of bases for the surface area, which means we got to think back to our chapter 10 formulas. And then hopefully with those things, you can put it all together. So thank you for watching, and hopefully everything goes well.